Coming up on this episode of the IoT Inc. Business Show.
Maybe it's not that bad that we actually have multiple protocols because they do have slightly different characteristics. I think the important thing is that we find ways to convert between these protocols without loss of information. And it's very important that the protocols actually carry the information with them that is needed to affect this conversion without having to resort to upgrading those converters each time you do something.
Okay, I admit it. This is going to be a bit of a geek fest. But application protocols are an important topic to understand if you want to understand how IoT works. Protocols are the lifeblood of an IoT system, and as we're about to find out, there are a few different types to choose from, each with their own characteristics and infrastructure requirements.
All this and more on this episode of the IoT Inc. Business Show. The people, the business, and the technology of the next generation internet. This is the IoT Inc. Business Show. And now, here's your host, Bruce Sinclair.
Hello and welcome to the IoT Inc. Business Show. This show is made possible by sales of my book, IoT Inc., published by McGraw-Hill, and the IoT Inc. Certified IoT Professional, or ICIP, online training and certification program. Become a certified IoT professional by completing the program's 3 courses: ICIP Technology, ICIP Business, and ICIP Strategy and Digital Transformation. Details of which can be found at www.iot-inc.com. That's www.iot-inc.com.
My name is Bruce Sinclair. I'll be the host of this panel, Top 5 Application Protocols in IoT Today. We have 5 guests joining us. Please introduce yourselves and go down.
Bhattacharya.
Michael Koster.
Steve Jennis from Prismtech.
Michael Richardson from Sandelman.
Carsten Bormann, Universität Bremen, TZE in Germany, and chairing the core working group in the IETF that works on the constrained application protocol.
So, guys, are we stuck with at least 5, 6, 7 application protocols? Is this just what we need to live with now?
Well, I think you're probably understating the problem there, Bruce.
All right, maybe.
In the sense that our focus at Prismtech is on the industrial internet.
Yes.
And, of course, every operational technology subsystem tends to have its own particular, whether it's proprietary or an open protocol. So I think the answer is yes, we're stuck with a multi-protocol world, particularly in the industrial internet, and we just have to learn to live with that. But at the end of the day, you need a backbone protocol that meets the requirements of the end-to-end system specifications. So
what is a back? Is that a protocol of protocols? Or
well, I don't think it's a protocol of protocols. I think it's a protocol that you choose. Has to deliver the qualities of service needed to solve the problem at hand and generate business value.
Okay, so you're saying is that there's going to be one, perhaps main protocol that you'll be using. Is that what you're saying?
Yeah,
for
I
the
guess
job?
Core, main, difficult terminology, but I think at the end of the day, you need a protocol that can, as I said, deliver the qualities of service end to end. If you haven't got that, then you're immediately constraining the value of the system. So don't you can get in a lot of trouble by going for maybe a cheaper, maybe a less capable protocol, and then find out that you can't achieve what you need to achieve with generating value from the data end to end. So it's like anything, if you go cheap, you might get shot in the foot,
Carsten Bormann, I would like to add that maybe it's not that bad that we actually have multiple protocols because they do have slightly different characteristics. I think the important thing is that we find ways to convert between these protocols without loss of information. And it's very important that the protocols actually carry the information with them that is needed to effect this conversion without having to resort to upgrading those converters each time you do something new. So, for instance, most of the protocols that are being discussed today carry information about the data format with them, together with the actual data in the data format. But then there are other protocols like MQTT which don't. So when you convert from MQTT to these other protocols, you actually need configuration information available to you to know what kind of data format you actually have. So there are small things that can help making those conversions successful and painless and upgrades without having to touch every node in your system.
Michael Richardson. So in the short term, in the home, I would say that the HTTP RESTful stuff is going to be the dominant protocol. For the large number of siloed devices which call home, it just makes sense. It's the only thing that they can reliably get through. The home gateways and other stuff like this is going to be HTTP. In the RESTful space, the thing that's happened over the last 10 years is that we've mostly, we came to RESTful and everyone thought, okay, we're pulling down XML, and XML is very nicely self-describing, but it's also quite verbose, and there's lots of little corner cases of it, and it's hard to parse properly. It's easy to parse poorly, but it's hard to parse properly. And so I think that's resulted in the rise of JSON. I mean, the other side of the reason the rise of JSON is that it's a JavaScript object notation, and JavaScript inherently understands it, and therefore the people building, applications that live in browsers, naturally it works so much better for them. And for IoT devices, it's possibly a toss-up, JSON versus XML. You can parse them both poorly. But I would claim that poorly parsed JSON is probably less harmful than poorly parsed XML. So that's an issue. But ultimately, I think that we will not have any of the significant benefits of IoT, particularly in the home, which involves mostly, the benefits really involve M2M type interactions. We will not have those benefits using the HTTP REST environment. It's going to have to be something else. I think the answer is probably CoOp, because it's probably mechanically translatable to the HTML. Not the HTML, the HTTP JSON. It's probably mechanically translatable, and it's simple enough that people can build CoOp devices which are both CoOp initiators and responders. Having said that, I wanted to add that one of the key things about the multiple protocols that Steve mentioned is that at some point, somebody is going to want to have a kind of God view of what's happening in the plant. All of the sensors, all of the data, all of the interactions. And to do that, it's going to be very annoying to have a lot of different protocols, particularly if they're not self-describing. So what I suspect is that what we're going to wind up, of course, the answer in all computer science is when you have a problem is you add another layer of indirection, right? And so what I think that we're going to have is an increasing use of a protocol, perhaps one of the IETF mile protocols, which uses the incident response format, so it's essentially syslog on speed, to basically describe things that are happening. So devices are going to emit unsolicited messages that say, something's going on, and other devices are going to collect that. And this is not going to happen in the low bandwidth sensor network, but on the edge device where the network and the backbone is. And that's where the monitoring system is going to want to look and say, okay, what's going on? Like, what's all the things? Show me all the gauges. What's happening? Oh my God, there's something happening over here. And my other sensor system didn't show it to me. So I think there's a protocol that's missing.
A higher level.
Another one, the audit and monitoring protocol.
That's not the protocol of protocols, though.
It's not the protocol of protocols. It's the protocol for diagnostics.
Got it.
Okay.
So the list that we have here today is CoOp, XMPP, RESTful HTML, MQTT, and DDS. Michael R. just discussed and placed CoOp a little bit higher level, at least, from a semantic maybe point of view, or is that a fair characteristic or characterization, or at least a little bit higher level point of view, but
from the resource requirement.
From the resource requirement. who wants to take a crack at basically categorizing the other protocols and kind of where they fit kind of relative to each other? Because I think that's just at a first glance, for someone just approaching this for a first time, what's the lay of the land? What's the anatomy here? CoOp, a little bit higher level. What about the other four?
CoOp actually is basically, it came from HTTP REST with a constrained device. It was designed like, HTTP REST was for a full capability devices embedded system. So CoOp was made from that, and it has got some good features of MQTT and other thing also. So those, I think CoOp is a good way to go about. But again, the DDS, if you look at a real time was, what Steve will probably say, the DDS is the right protocol when you are trying to see at a higher, quick response time, and also allow all the particular edge devices and everybody to share the common data. Right.
Yeah, I think, obviously I'm biased here as a DDS vendor, but trying to be as unbiased as I can be, qualities of service are manifold. You have scalability, you have throughput, you have latency, you have agility, robustness, efficiency, bandwidth efficiency. All of these qualities of service need to be assessed in terms of the system solution. Many systems maybe don't care about low latency. A few hundred milliseconds or a few seconds maybe doesn't matter in a human environment. As we have today with Facebook, nobody really cares about millisecond latencies in Facebook. But particularly the industrial world gets very sensitive about robustness in terms of if a node on the system goes down, what happens? If you need to add a new node to the system, what happens? If you have bandwidth constraints, how do you optimize the efficiency in that part of the system? If you have latency requirements, value from data doesn't just come from big data. Okay. Value from data comes everywhere in the system. So you have to look, and what we're finding is that when people look carefully, they tend to find that the more lightweight protocols, whether they come from an internet heritage, instant messaging, or they come from a telemetry heritage like MQTT, they can't quite cut it for parts of the system.
All right.
And that's where that leads them back to DDS.
So I want to jump up higher level again, guys. I want a one-word summary or adjective for each protocol. DDS. One word.
Quality of service.
Mike, for XMPP. QoS. QoS. Give me one for XMPP. Or someone else who feels more comfortable. One word.
I would say for
adjective.
RESTful is ubiquitous.
RESTful, okay. Carsten, XMPP or MQTT? Which one you want to take?
I'm not sure that works. So the one word you would have for CoOp and HTTP is REST.
Okay.
The one word you would have for XMPP and MQTT is message. And so those two lend themselves very nicely to event-based processing, but they have the problem of all event-based mechanisms that if you run into an overload situation, you don't know how to handle this. And so one thing we did when we added events to CoOp was to add eventual consistency, so we have a way to continue processing in case we have more events than we actually can process. And really what DDS is not so much a protocol, it's actually an infrastructure, an API, things you can program against. There are multiple protocols in there, so if you are laying out your data center infrastructure, DDS is one way of interconnecting your components. But there are lots of things going on under the hood, so it's not quite the same as the other four.
Just one very quick comment on that. We actually don't refer to DDS as messaging. We refer to it as data-centric integration, and that's a very important differentiation, the difference between data-centric and message-centric systems. And we have no time to go into it here, but that's fundamental to not being dependent on message brokers, for example, as single points of failure. But we can get into a lot of
data
detail.
centric and message centric. If it's central, let's spend a couple minutes on that. Who wants to take a crack at it?
Well, the data centric means that the data is the key that resides in a database, and it is shared among anybody can get access to the data. What happens in many of the other protocol, how the servers are set up, you have to go through a couple of hops, right?
That's for the message version,
For the message versions kind of thing, the servers are set up so that you cannot get some other analytic server want to get access to the data. It has to go through some other servers to get into the message kind of thing. Mm-hmm. So
that would be XMPP and MQTT?
That will be XMPP and MQTT kind of thing.
And and CoOp, RESTful,
right.
and
the
DDS.
point is it has to pass through brokers. So broker and the broker give it to a server, and then in the back end, it can direct, that server can copy it to different servers.
Yeah. Just another aspect of it is one key attribute of DDS is content-based filtering. So one of the ways that you determine delivery priority and real-time performance is through classifying the data packet based on its content. In messaging, you tend to not know what's in the message. You just queue the message, deliver the message without any visibility of its content. So data-centric can be described as prioritizing delivery on the content of the data packet.
And what would be some examples then of IoT applications that are more message-oriented versus IoT applications that are more data-centric oriented?
Okay, I'll have
Everyone's taking a deep breath.
Deep breath. I think it comes back to the quality of service analysis that I talked about earlier. Data-centric architectures are much better at some aspects. When you look through, DDS has 23 configurable qualities of service. MQTT has 3. So that sort of tells you the difference in capability of the approaches. So when you look at that, it quickly tells you whether a data-centric or a message-centric approach is more likely to solve the problem.
So then, what about message-centric approach? Where is that play then? Where is that strength?
Michael Richardson. So, if you haven't read, there's a ACE use cases draft that's from the IETF. It's very nice because it's lots of interesting use cases that have real names and, or at least have interesting names attached to it. And so one of the examples is Bananas for Munich, okay? And it's about containerized smart containers that know whether the bananas have gone rotten or not, and if they did, whose fault it was. And my impression is that that's much more message-centric because the information, the quality of service of the information is important but not particularly urgent. There isn't a particular reason to say this data is more important than other data. What's more important about that in that whole process is connectivity, that the box of bananas can communicate with the container as to its state. The container can react, okay, and say, I'm going to get colder, I'm going to get hotter. The container can indicate to the ship or the truck or whatever, I haven't got enough power to cool, right? It's gotten too hot. My cooling system's broken, whatever. Those are the kinds of things. And any of those messages are probably of about the same quality, and maybe three levels is very generous even in that situation. But mostly what it amounts to in the end is the most important part is the audit log at the end of the day where the supplier and the recipient can point to the appropriate entity in the supply chain and said, you screwed up, right?
Right.
You have to fix your system, and it doesn't really matter why you screwed up, okay, but you need to fix it.
Thank you for referring to the container example. It may interest you that we actually built this based on CoOp, because there are some data-centric aspects to that as well, and the event-oriented parts come quite naturally either by using CoOp Observe, or actually by having parts of the system put data to other parts of the system. Right. So we can handle the event aspect this way, And since much of the information in that system really is status, specific measurements on a large number of measurement devices, the data-centric aspects are actually very important as well.
So if the data-centric approach can be more or less the superset of the message-centric approach, then where is the messaging architecture? When would you want to use a messaging architecture rather than a data architecture?
So let me just give an example. The message-centric architecture was invented in order to make sure that businesses don't lose events. So if somebody comes in and sends you an order, you really want this order processed. That's the important thing. It's not the fact that the number of orders you have in your system increased from 1007 to 1008.
Or
it's
when.
the order itself. That is a message that needs to go through an enterprise service bus, reach the right points. And that's where the message architecture actually excels. And on the other hand, if you have many sensors in your system and they all provide data, then first of all, the thing you see is there's lots of data. Now, some of these data may change, some of these data may reach thresholds and so on, and that might also be modeled as a message. But it's a little bit like waves and particles in physics. It's dual to each other.
Right, I'm not going to get into the coexistence of particles and waves, but I think it's very important. I said earlier in response to an earlier message that you look at the heritage to see where these things come from. You've mentioned order processing. DDS fundamentally comes out of a real-time distributed systems world, originated back in the 80s in combat management systems, where you have a shipborne Internet of Things or Net of Things, where you have sensors, you have command and control systems, you have SATCOM back to the Pentagon or wherever, and you have human intervention, and you have actuation, fire control systems. You think about that, it is a high-performance Internet of Things, just a Net of Things then. NASA launch control systems, hundreds of thousands of sensors being monitored in real time, producing huge amounts of data. That's the heritage of the data-centric approach. So the fact that it's easily applicable to industrial internet is fairly obvious.
Okay.
It's really just embracing the internet beyond the net.
And what about the heritage of the other protocols? Can someone shed some light? There's another dimension to look at it at.
See, one of the thing is messaging is a simple kind of protocol, right? That's how the MQTT and wherever the cellular kind of network is there, and occasionally you want to send information, that you are not sending a huge amount of information. There, DDS kind of elaborate thing is a kind of overkill. Whereas where you have a good bandwidth and good kind of reliable network on which the DDS can be a better fit. So, there are multiple candidates, CoOp and DDS, and you can look at all the different advantages and disadvantages. And where you say that server, I want to take it out and put it back, or whatever it is, or the quality of service, or you have got multiple datas that are driving one particular industrial internet in case of that. So it's basically, suppose you have got a furnace, higher temperature, and whereas the particular, maybe another information that humidity is low, or certain other thing is happening with the plant, the plant is on a weekend or some other thing, the number of people are there less. So the particular thing that you can predict certain kind of events happening is much worse kind of a thing, right? So you can actually sum up some of the datas, multiple datas are driving to one conclusion. So that particular thing is better for it.
Yeah, and what we're finding is that the scope of industrial is broadening every day. Wearable heart monitor, where you can get an online EKG with 30 to 50 updates a second, suddenly becomes a critical distributed system where healthcare might not have been regarded as industrial historically. So what we're finding is that more and more systems become quality of service sensitive across all of many different domains like autonomous vehicles, healthcare systems, power generation, power distribution, smart grid. So that's where DDS really thrives because of its heritage.
Michael Richardson again. Yeah, some of the wearables people like to say, people are things too. Yeah, that's right. But I was reading recently, there's in the Linux space, they have a bus called dbus, and there's some enhancements to it, and there's some other things in that. And also Android phones have another bus that is also, that launches your applications. And these are message buses, because when you launch the application, you really don't want it to get lost. It's not something that there's no quality, there's only one quality of service: deliver it or crash, right? That's really it. So anyway, so I was reading that one of the reasons for the dbus performance improvements is it turns out the automotive Linux people, when you turn the ignition on, there was something like 150,000 messages that went through in the 2 seconds that your ignition key was turned. And I was quite astounded by this. I have no idea what what these messages actually do. My suspicion is that 10% of them are messages, commands, things that need to happen, right? And that the other 90% of them are statistics being thrown around the place, which actually are more of a data-centric kind of thing. And some endpoints care about them, and some endpoints just care about what the last temperature of the engine is, they don't care about the intermediate, 12, because you need to adjust based upon the current one. And if you lose some data, that's okay. It's not great, but it's okay. On the other hand, if you lose the signal that says, please turn on the windshield wipers, that's a problem.
Yeah, I think that's a very good point about data integrity as well. You talk about deliver or crash, but what do you do after you crash when you come back online? How do you ensure the integrity of data? And that's another advantage of a data-centric approach, is that lost messages can be critical. Okay. Absolutely critical if they're not restored in a chronological order or in an order of priority. So data centricity also means that you have the ability to cope with instability in the system and recover, another term for robustness, recovery, in a smooth way. And so again, things that spin, whether they're car engines or turbines or jet engines, they throw off incredible amounts of data, as GE informs us on a regular basis. So the value in that data is oftentimes not fully understood, but it preserving it and having it distributed and shared in a consistent manner is key, and that's another value, I said, of data-centric architectures.
Carsten again. I'm from the city of Bremen, and one of the things that we build in Bremen is parts of the Ariane space rocket. And when the Ariane 5 was tried for the first time, unfortunately it exploded, and took people a couple of months to find out what exactly had happened. And what had happened was that a particular subsystem was generating events much faster than the rest of the system could process. And the system was not able to handle this burst of events. If they had done it in a data-centric way, we would have a successful first flight of that rocket.
Yeah, and I think another non-industrial but easily understood application is in high-performance trading systems on Wall Street or in London. They talk about a millisecond being worth $1 million, and when a traumatic, use the word traumatic carefully, but a traumatic event like an interest rate change by the Fed, I mean, everything goes bananas. It's millions of messages a second are nothing. Tens of millions, hundreds of millions of messages, because everyone is trying to arbitrage that change in interest rates very quickly to make money, to make a killing. So it's not just industrial systems that have very high value, low latency data. Financial systems do too.
So my daughter likes to say this is a first world problem. And then I heard earlier in this conference someone was talking about the need to be able to turn on and off their jacuzzi as a VC world problem.
And now no one else is really thinking about those problems. And then these traders, man, we'll just call those the high volume trader problems. But they are a problem that people pay money for. And,
well, those mathematicians, they earn millions, right?
Yeah.
The quant guys, just writing algorithms to process this data faster than the guy down the street.
When I listen to a podcast, I like to, get out of my car at the end of the podcast and at least have 1 or 2 nuggets of new information. I spent, 20 minutes on it. That's okay, and I don't mind going through all the white noise. I like to take some value out of it. So what would be the value in this case for me? I would be taking away the messaging versus the data. Any last thoughts as we conclude this as a takeaway from, at a very high level, as a takeaway from this interview?
Yeah, the main thing is that all these application protocols, they came from a particular need, or what Steve calls a heritage. So that particular need was satisfied by that particular application at that time. And some of these things you cannot eliminate because of the bandwidth or some of the requirement on which they are sitting. So until and unless you do that kind of constraint kind of design of this thing. And obviously, more and more we are going into the data world where there is a uniform bandwidth and quality of services available. So depending on that, so there are multiple application protocols are going to coexist, and there would be ways that this different data and other information can be translated from one protocol to the other. So that is another thing that people are working on, like JSON and other kind of different things, and it is changing. So we need a complete solution, as yesterday Carsten's talked about, that all of the object model, data model, we need a complete solution to see how the information from one particular protocol can be given to another protocol and interworking can be satisfied.
Okay. Any other concluding words? We got a couple down.
I would say that we're at the start of a journey over the next decade in terms of reaping additional business value out of data access. I think the important message to take away is don't constrain the potential of your data by putting in an infrastructure that's incapable of delivering the data to the required quality of service.
Are you going to be talking about freeing data again?
I'm going to talk about free data.
Are you going to be doing that again?
Yeah. No, all I'm basically saying, obviously there are security concerns. Obviously there are subsystem integration issues like gateways, and these problems have to be addressed, and some of these subsystems, proprietary, will be around for a long time. But, don't build a 2-lane road and then a year later realize you need 4 lanes.
Right.
Okay, and so that's why we strongly promote DDS, because it gives you the 4 or 5 or 6 lanes that you need to move the data around the system. And who knows where the value will come from. We didn't predict Facebook and Twitter and Instagram 10 years ago. Most of us didn't anyway, but who knows over the next 10 years what apps are going to be killer apps in this world. But don't let the data sharing infrastructure constrain what you can do.
Michael Richardson, I would say almost the same thing and also the complete opposite at the same time. Don't let your data be constrained by the protocol that you pick, because it's probably the wrong protocol. So make sure that your data is self-describing and that you've thought about it, how it will work. And in particular, we talk about sensor data, but when you talk about actuating data, think about how you can redescribe that in RESTful way much that it's sensor data, because every activity needs an audit stream. So if you think about it that way, then it becomes much easier, and that actually feeds into all of the different protocols that we've discussed, whether they are message or data or whatever. Every activity has an audit stream, and that's how that has to go back out.
Yeah, I think we have discussed the properties of the various protocols, and they have different properties. Look at them, compare them, find out which one fits. But I think it's also very important to remember we are going to have these protocols around for a long time. None of them is going away. They may shift in their relative importance. And when selecting a protocol, also think about how well it actually integrates with the rest of the world you need.
All right. Well, with that, I think we'll end the interview. We'll end the podcast. Thank you, gentlemen. I feel enlightened about application protocols, and hopefully our listeners do as well.
Okay, that was an informative panel talk. This podcast goes vertical, deep diving into different topics each week. If you prefer a more horizontal and structured approach to learning IoT business and its orbiting technologies, check out my book IoT Inc., published by McGraw-Hill, or become a certified IoT professional by completing the ICIP training and certification program. For details, just go to www.iot-inc.com. Also go to www.iot-inc.com for an analysis of this episode, links to things that were mentioned during the episode, and very importantly, the episode's PDF transcript. Just search for the name of the episode or the guest. If you're new to this podcast, subscribe. That way you'll get every week's episode delivered straight to your device. Or, if you've been listening for a while, there are 3 ways you can support the show. You can leave a rating or a review on iTunes. Just go to iot-inc.com/iTunes. It only takes 1 click to leave a rating, a little bit longer to leave a review. You can share it on social. I'm on LinkedIn, to a lesser extent on Twitter. And of course, you can support this show by buying my book, IoT Inc., or the ICIP training and certification program. It's how I pay the bills. Next week's episode is another great panel, a symbiotic partnership between standards bodies and consortia. Hope you can join me then. I'm your host, Bruce Sinclair. Thank you for listening. Until next week, may your path to IoT business be a message-based or a data-based one.
You have been listening to the IoT Inc. Business Show.